If you can write code, you can create beautiful art for your game. Programmer art is an old joke, but lots of programmers just feel like they don't have the skills to create art. I would argue tech art is actually the best way to create a unique visual style on an indie budget. It lets you take assets or base meshes and give them a whole new visual identity, and you can get really efficient with this workflow. I've made quite a few videos on the benefits of tech art at this point, but in this one I want to show how just a little bit of code took a flat, honestly ugly effect from my game Donut Panic and made it both feel better to play and much easier on the eyes. We'll be cooking, glazing, and sprinkling a donut as an example, but the hope is to open your mind to some techniques to code your way to better visuals. Just before we get to writing code, we do need a base model to work with. While you could generate a donut mesh through code, I promise it's a lot easier to do it in Blender. I'm adding a torus, tweaking the parameters to get the shape I'm after, right click and shade smooth, and then adding a subdivision surface modifier because I want a lot of vertices to work with. Obviously, more vertices comes at the cost of performance, but we'll be creating a well-optimized effect that I've already tested on low-end devices like the Steam Deck, so I promise we're just fine. But that's it, from here on out, it's all code. Now, before we can glaze this donut, we of course need to cook it. I've set up a couple materials in Unity to represent uncooked and cooked states. I'm basically just changing the color and the smoothness with the cooked material, but I want to keep this video general purpose as possible and not super specific to donuts, so I'm going to show you a useful technique for smoothly transitioning between any materials that share the same shader and textures, allowing us to create more complex transitions. Here's what we'll do. We create a donut prefab with an uncooked material as the starting state. Then when we start cooking, we create a copy of that material so that we can modify the properties of this individual donut without affecting any of the other donuts. I like to create a mapping from original material to copy, ensuring we only create one copy per material. This means if we have 3 LODs using the same material, we only create one copy rather than 3, and if you add more renders as prefab, it's all going to work really nicely. As the donut cooks, we can blend between the uncooked and cooked materials using the lerp function. Lerp stands for linear interpolation, and the idea is that given 2 values, a and b, and a transition variable t, if t is 0, we get a, if t is 1, we get b, and if t is anywhere in between, then we get a linear blend between a and b. I have a cooking state float which goes from 0 to 1 as the donut cooks, so I can just plug this in as the t value and get a really smooth transition. Lerp is typically used for floats, vectors, and colors, but Unity does provide a lerp function for materials as well, which lerps over all the properties on the materials, allowing you to create complex transitions with just one line of code. The only restriction is, the materials do need to share the same shader and ideally the same textures. Nice, and you can imagine extending this for a well done or burnt state, doing this for all the cookables in your game rather than just donuts, and really using this technique to transition any materials, even for particle systems. There's a lot you can do with this. Just don't forget to clean up any materials you create, otherwise you've created a leak. Okay, we have a cooked donut, now let's add some toppings. Now, a low effort game might just have you press button to glaze and turn the glaze model on. But with just a little bit of code, we can create a much more satisfying mechanic that's better to play and more pleasing to the eyes. We'll start by casting a ray from the camera to the donut to find the point on the donut where we're looking as we're glazing. This is the local position where we'll apply the glaze. With this and a few parameters to control the visuals of the effect, like a radius and a color, we're going to start populating the vertex colors of the mesh. Just like each vertex has a position and a normal, it also has the color property, which is just a vector 4 that we can fill in with whatever data we want. And we're going to use this to define the glaze color in the RGB channels and the glaze intensity or the strength in the alpha channel. Later, we'll then access that color data in a shader to render the glaze and in a VFX graph to spawn sprinkles. Alright, let's start modifying our mesh. Just like the cooking material, in order to operate on this single instance of the donut, we want to create a copy of the mesh. Now I have about 2,500 vertices that I'm working with here, so I can't just run a for loop over the entire thing and expect to maintain a solid frame rate. We do have a couple options for maintaining performance though. One option would be to run the logic in a compute shader, but my game is already heavily GPU bound, while the CPU is relatively idle. So instead, I'm going to keep this in C# and I'm going to run the logic in parallel off the main thread using Unity's job system. Again, I've tested this effect on low power devices like the Steam Deck and we're perfectly within reasonable performance budgets running this on the CPU, even with a couple thousand vertices per donut. Don't worry though, we will get to some shaders soon. We'll initialize a couple native arrays to represent the vertices and the colors of our mesh. Oh, and just like our mesh copy, we don't want to forget to clean these up when we're done with them, otherwise we're leaking memory. Inside the job, we're going to read the current glaze intensity from the alpha channel, which will be 0 to start, and add to it based on how near the current vertex is to the point that we're touching and the radius of the effect. We can also make the glaze a little less rigid and feel like it's kind of oozing away from the brush by adding some easing and some randomized noise, giving it a much more organic shape. And that's really it. With the job ready to go, whenever we're glazing the donut, we can then initialize and schedule the job with our input data, and we'll wait for it to complete on the next frame. Once it's done, we copy that colors array back into the mesh, and then we can pass a few flags to tell Unity not to bother recalculating data unnecessarily. This is just a simple performance optimization. And that's it. Now we have a mesh populated with all the information we need to render our glaze. Now, if you're watching this and feeling like it's all a bit above your skill level, or you're an aspiring programmer who doesn't know where to start, Coddy is a fun and interactive way to learn how to code. Think Duolingo, but for coding, and the best part is, it's free with a daily usage limit. When you sign up, you'll answer a few questions, and Coddy will put you on a learning journey tailored specifically to you, guiding you from beginner to advanced coding skills. Their interactive challenges make the learning process engaging. Each journey offers you practical experience through coding challenges, quizzes, and real-world projects, and their bite-sized lessons make learning to code less overwhelming and easier to digest. Coddy helps you stay motivated by tracking your learning streak, and you'll even earn rewards and progress through challenges in a fun, competitive way. It's great for beginners, self-learners, and aspiring developers who need a platform that breaks coding down into manageable, interactive steps. Whether you want to learn a language like C#, C, JavaScript, or Go, or you want to pick up specific skills like sorting algorithms or data structures, Coddy has loads of courses to choose from so you can learn the practical skills that you need. To get started for free with Coddy, head to coddy.tech and start learning how to code. Huge thanks to Coddy for sponsoring this video. Okay, here's where code really becomes a superpower: shaders. Shaders are simply code that runs on the GPU, and among other things, they let us manipulate vertices and output colors based on our own logic. There are two main ways to write shaders in Unity, using the HLSL programming language, or shader graph, which just gets compiled down to HLSL anyways. To keep this video as accessible as possible, let's go with shader graph. The principle is exactly the same in HLSL though, don't worry. Now that we have a mesh with our glaze data stored in the vertex colors, let's write a shader to create the perfect glaze. And by the way, we're going to create a VFX graph which uses a very similar technique in just a minute to sprinkle the donut as well. For the glaze shader, we'll start by simply outputting the glaze color to make sure we're populating the vertex colors properly. That seems to work, but we do have two problems. The first is that it's showing everywhere, and the second is that it's sort of flickering. Let's tackle the flickering first. This is happening because we're rendering the same mesh twice at the exact same position, once for the dough, once for the glaze. So the GPU is struggling to sort the rendering of these two meshes. We can solve this and also give the effect some depth by pushing the vertices that have been glazed so that they grow up out of the donut. And then the vertices that haven't been glazed can be pushed down so that they're hidden underneath the donut mesh. One of the main goals of the vertex shader is to simply output the vertex position, but that means we can also manipulate that position based on our own logic. This is called vertex displacement, and it's a very common technique for wind and wave effects. Let's take the strength of the glaze from the alpha channel of our vertex colors, which will be between 0 and 1, and use that to lerp between some small negative value to hide unglazed sections beneath the dough, and a small positive value to extend glazed sections above the dough. We do need to know what direction in 3D space to push the vertex though, and we can get that from the normal vector, which is basically the up vector of that vertex. So a positive value will raise it up, and a negative value will lower it down. Multiplying this float by the normal vector gives us the displacement, and then we can add that to the default vertex position to complete the displacement effect. Nice! The more we glaze a particular location, the higher the alpha value in that vertex color becomes, the higher we raise the glaze in that location, giving a really satisfying sense of adding more and more glaze to the donut. And guess what? This also solves our color issue, since the unglazed portions are no longer visible. This is already a great start, but it is looking a little bit flat. Let's push the effect a little bit further. First, I want the glaze to feel like it has some depth to it, and an easy way to give a sense of depth is to shade or darken the edges. It's the same as drawing a flat circle versus a three-dimensional sphere. It's the same principle here. Let's add a bit of logic to darken the glaze in places where the alpha value is particularly low. We'll divide the alpha value by 0.4 and saturate to clamp the value between 0 and 1. Now when we have a value of 0, we want to fully darken the glaze, and when we have a value of 1, we want the proper glaze color. And of course we want a smooth gradient between. I bet you see where this is going. Let's use this as the t value of a lerp, with A set to the darkened color, which is simply the glaze color multiplied by a low value, and B the original color. It doesn't look like much zoomed in like this, but in-game it's going to go a long way to adding some depth to the effect, and we're able to control how strong the effect is. This helps a lot, but the main glaze still looks a little bit too clean for me. One of the great laws of tech art is that noise is your best friend. Noise algorithms are very handy, but in this case the noise I want is static, so it's more performant to just generate a texture for our noise. I'm using something called cell noise here, and I'm making it very minimal. We'll then blend this texture into our glaze color by simply multiplying it. This gives the glaze a very subtle texture, maybe like there are little blueberry, chocolate, or vanilla chunks in the glaze, but the point is that it adds a tactile feel to the effect and looks much better, at least in my opinion. It's a matter of taste, of course, but layering in noise to your art is a great way to break up repetition and give your environments a much more tactile feel. In fact, in my shader used to render all the standard geometry in the game, I'm using the exact same technique to layer in a grimy noise texture, which just gives the whole environment a bit more sense of being a real place, of being lived in, and takes away some of that flatness you see in a lot of indie games. Cool. This glaze is feeling really good, and of course we can keep going further and further with this. For instance, let's add a normal map, which is just a nice addition to give the effect a bit more texture. As promised though, this doesn't just work for shaders. We can also use this effect in VFX Graph to spawn particles as well. VFX Graph comes with a sample mesh node, and if we make sure that color is enabled in the output, then we have all the data we need to sprinkle a donut. We can render sprinkle particles all over the donut mesh, and control the size of the sprinkles with the colors alpha, and then set the particle's alive state to false when the alpha value in the vertex colors is nearly 0. Now the exact same glazing logic works perfectly for sprinkling. Now, I know you're probably not making a donut game, but hopefully this helps show the power of tech art, and how a little bit of code can be a real superpower when it comes to creating beautiful and interactive effects for your games. Thank you so much to all my patrons, with a huge special thanks to my ospreys Elegon, Jason Hansen, Ellie Swaley, Justice Lind, Brendan Pung, Peter James, Will Todd, Neil Blakey Milner, Peter Randall, Alan Halstead, Josh Temple, and Kuro Pebbles. Thank you all so much for watching, and I will see you guys next time.